Hello student, good morning. Myself Jinendra Kumar. Today we are going to solve the numericals of class 9th physics chapter number 2nd work and motion law of motion. In this chapter, in the volume number 1st, we solve the internal questions of this chapter, and today we solve the exercise of this chapter. The question is given here. Question number first, we solve this question. A truck starts from rest and rolls down a hill with a constant acceleration. It travels. Oh, the value is given. Truck starts from rest. Initially, the truck is in rest position, so initial velocity is equal to u is equal to 0. It travels a distance of 400 meters. So s is equal to 400 meters. Distance is 400 meters in 20 seconds. Time is given t equal to 20 seconds. Find the acceleration. Find the force on acting if its mass is 7 metric ton. Mass m equal to 7 metric ton. We know that 1 metric ton is equal to 100 kilogram. Then 7 metric ton, 7 into 100 equal to 700 kilogram. Mass is 700 kilogram. We have to find its acceleration. We show here first equation of motion, v equal to u plus ab. Because b is not given here, initial velocity is given and acceleration. Find out t also given. V and a is not given here, so we cannot use this equation. Second, s equal to u t plus half at square. S is given, u also given, t given, we can find acceleration. So we use this equation. It is the equation of second. From the second equation of motion. It is s equal to ut plus half at square. Here s is distance covered by the body, u is initial velocity of the body, the object, t is time, and a is acceleration, and t is also time here. So be putting the values. S is given 400 meters. Initial velocity is 0 into time is 20 seconds plus 1 by 2. Acceleration we have to find. T is 20. Square of 20, 20 into 20. 2 times the 20. It will be 0. 400 plus 0 equal to 0. 2 1 2. 200. 20 10 200. A equal to 400 divided by 200. We cut here 200 1 200, 200 2 400. A equal to 2 meter per second square. It is acceleration, which we have to find out. It is the acceleration 2 meter per second square, and we solve find the force acting on it. We have to find force acting on it. We use the second law of motion. From the second law of motion. Law of motion. Second law of motion. Second law of motion states that the force acting on a body mass m, the force is equal to mass, body mass, and the acceleration, the product of mass and acceleration, F equal to m. We put the value here. Mass is given 700 kilogram, and acceleration we have find 2, 7 to the 14. No. Kilogram. 1 metric ton is equal to 1. We so here it is a mistake because 1 metric ton is equal to 1000 kilogram. We know that 1 quintal, when 1 quintal is equal to 100 kilogram, what 1 metric ton is equal to 1000 kilogram. So it will be 7000 kilogram. So we put the value here 7000 kilogram. So 7 to the 14 triple 0, it is the force will be 400 Newton. The force which act on the truck is 400 Newton. So it is the solution of this question. Next question, question number second. Question number second is saying that a stone of 1 kg. Question number second. A stone of 1 kg, m equal to 1 kilogram. Mass of stone is 1 kilogram. With a velocity of 20 meter per second. Stone of 1 kg is thrown with the velocity of 20 meter per second across the frozen surface of the lake and comes to rest after traveling a distance. So it is the initial velocity of the throw stone is 20 meter per second. Frozen surface of a lake and comes to rest. So final velocity v equal to 0 because the stone comes in the resting position into rest, traveling the distance of 50 meter, and the stone traveled distance equal to 50 meter in this period of time. What is the force of friction between the stone and the ice? We have to find force of friction. What is the force of friction? It is the surface and stone is initial velocity u equal to 20 meter per second, and after traveling 50 meters it stops, and here the final velocity v is equal to 0. We have to the force acting on this. So from the equation second equation of motion. Time is not given here, so we cannot use this second equation of motion. So we know that the third equation of motion is v square equal to u square plus 2as. Final velocity, initial velocity, this distance is also given here. So we use third equation of motion. From third equation of motion, so v square equal to u square plus 2as. Put the value. Final velocity is 0, 0 square. Initial velocity is 20, 20 square plus 2. The a into s is given 50 meters. Calculate 0 equal to 20 square of 20 is 20 into 20. What we write here, this 2 into a into 50 is equal to, when we take 20 square another side, it will be minus 20 into 20 minus 20 square, and square of 20 is 400 minus 400. We have to find a equal to minus 400 upon 2 into 50. We divide 4 minus 400 by 2 and 50. Cut 0 from 0. 5 8 is 40. 2 4 is 8. So acceleration is 4 meter per second square. What we have, find the force of friction between the stone and the, because the force is of friction, it is acceleration is 4 meter per second. Force of friction F equal to, from the second law of motion, ma, mass is 1 kilogram and acceleration defined 4 into minus 4 Newton. It is the force of friction. The force which stops the stone is called force of friction. When we apply the force in this direction, the force of friction between the surface and the surface of the stone is called force of friction. When we throw the stone in this direction, what the force of friction acting on the stone in the backward direction, and it will be equal to the force of in same direction, so it will be minus 4 Newton. F equal to minus 4 Newton. In this way we find the solution of this question second. Next question number 3. In the question 3, 800 kilogram engine pulls a train of 5 wagons each of 200 kilograms. The mass of engine is given Mass of engine. Mass of E equal to 800 kilogram. 8000 kilogram. Pulls a train of wagons 5 wagons. Big is considered it is a train and it pulls the 5 wagons each mass. The mass of engine is 8000 kilogram and the mass of each wagon is 2000 kilogram, 2000 kilogram and 2000 kilogram, 2000 kilogram and 2000 kilogram. In this way, total mass along a horizontal track, if the engine exerts a force of 4000 Newton and track over its value is wrongly given here 40,000 Newton. 40,000. If the engine exerts a force of 40,000 Newton and track offer a friction force 500 Newton, then calculate. We write here the given value. The mass of wagon W is equal to mass of each wagon 200. So total mass of wagon mass of total mass of all wagons. Total mass of 5 wagons. 5 into 2000 equal to 2 5 is 10. 10,000 kilogram. Total mass of train is equal to capital M. Sorry, M is equal to mass of engine plus mass of wagon, 5 wagons. Mass of 5 wagons is equal to 8,000 plus 10,000. It will be 18,000 kilogram. Total mass. But the force of the engine is 40,000 Newton. The force which applied by the engine is 40,000 Newton force. But the track applied the friction force of 500 Newton. It is equal. When train pulls the all wagons and goes in ahead, goes in comes forward, it exerts a force of 40,000 Newton in the forward direction. What a force which acting on the track in the opposite direction is 5,000 Newton. We have to net force. Then the net force which pulls the train equal to 40,000 total force minus force of fraction, fraction force. We subtract from 40,000, we subtract 5,000 from 40,000. It is 40,000 and force of fraction is 5,000. So it will be 35,000 Newton. Calculate the net accelerating force. It is the net accelerating force because 5,000 Newton force is work in back direction. What it is in forward direction. So we subtract for 5,000 from 40,000. It will be 35,000 Newton. Next point is the force of wagon 1 on wagon 2. In this condition, we have to find the force of wagon 1 on wagon 2. Wagon 1, how much force applied on the wagon 2? We see here wagon 2, wagon 3, wagon 4, wagon 2, 3, 4, 5 connected with wagon 1. So total mass of these wagons will be total mass of 4 wagons equal to 2 into 2, sorry, 4 into 2000 equal 4 to the 8, 8,000 kilogram. The force applied by second, by first wagon to the second is F equal to ma. Mass is 8,000 and acceleration is 'The acceleration of the train'. We have to find the acceleration of the train. First, we find the acceleration of the acceleration. You know, F equal to ma. F equal to ma. So from this, A equal to F upon m. F upon m. Force is 35 Newton, 35,000 Newton, and mass is, total mass is 18,000. We cut 0 from 0, multiply, divided by 15, 18, 18 1 ja, 89 ja, 162, 8, 18 4 ja, 72, again 8, and it will goes on. It is 1.944 meter per second square. A equal to 1.944 meter per second square. What in third point, we find out the force of wagon 1 on wagon 2. wagon first, what is the force which wagon A या wagon 1 apply to wagon 2? Because in this series on the second wagon, third, fourth and fifth wagons also connected. So total mass of these wagons will be total mass of 4 wagons equal to 4 into 2000 is equal to 8000 kilogram. F equal to ma, mass 8000, and acceleration we have find 1.944. We multiply it. We remove the decimal from 1, 2, 3 all zeros and multiplied 8. 8 4 ja 32. 8 4 ja 32 plus 3 35. 8 9 ja 72. 72 plus 3 72 plus 3 75. Carry 7. 8 1 ja 8 plus 7 15. It will be 15,552 Newton. The force which act on second wagon while the first wagon is 15,552 Newton. In the next question number 4. Question number 4 is saying that an automobile vehicle has a mass of 1500 kilogram. Question number 4 also. An automobile vehicle has the mass of 1500 kilogram. Mass is 1500 kilogram. And what must be the force between the vehicle and the road if the vehicle is to be stopped with a negative acceleration 1.7? Negative acceleration A equal to minus 1.7 meter per second square is given here. Mass and acceleration. Simply we solve this question from the second law of motion. F equal to ma. Mass is 15 kilogram and acceleration is minus 1.7. Save 1. We remove decimal from a 0. 17 0 0 17 5 85. Carry 8 17 1 17 8 25. Negative sign. It will be 2550 Newton. It is our solution. Because the truck in this question vehicle automobile work on the negative acceleration. The vehicle is moving in the forward direction, but the force of friction between the tire and the road stops this vehicle and with the acceleration of 1 point, negative acceleration of 1.7, and the truck goes on, and after some time it stops. So the acceleration is minus 1.4 applied in the backward direction, but we have to find out the force between force of traction. Simply we use second equation of formula of the second equation of second law of motion and find out the solution. Next question, question number 5, solution. Two objects each of mass 1.5 kilogram. M1 is 1.5 kilogram and M2 is also 1.5 kilogram. Are moving in a same straight line but in opposite direction. Two objects, a blocks, move in the same line but in the different direction. M1, it is M. The velocity of each object is 2.5 meter per second. V1 is equal to 2.5 meter per second and V2 is also 2.5 meter per second. The velocity is same each object. Before the collision, during which they stick together, what will be the velocity of the combined object after collision? We have to find the velocity of combined object after the collision. Before the collision, during which they stick together, what will be the velocity of the combined object after collision? Velocity of each object is known. Before the collision, during which they stick together. They stick together. We solve this question. The change in momentum. Before the collision, it goes in opposite direction. So we write here m1 v1 plus m2 v2. This velocity in the negative direction. So m1 is 1.5 into b1 is 2.5 plus m2 is 1.5 also, and it is 2.5. Multiply it. 25 5 the 125, carry 12, 25 25 plus 12, 37 plus minus 375. 0.375 minus 0.375 is equal to 0. Okay. When they struck each other, because mass is same and velocity is same, but the direction is different, when we collide, it will be uh, mass will be initial moment, total momentum before collision. The total momentum after collision equal to total mass m1 plus m2 and velocity. We have to find mass is 1.5 plus 1.5 and velocity we have to find. It is 3.0 v. The total momentum after collision, in this case total momentum after collision is equal to total momentum before collision. Total momentum after collision is 3v is equal to total momentum before collision. We get 0, v equal to 0 by 3, it will be 0. In this way, we find that the velocity after collision will be 0 in this condition. So in this way, we solve all the questions from question number 1 to 5. You can practice, and you have any queries, you can ask with the comment box or WhatsApp number. WhatsApp number is given in the thumbnail. Thank you for watching.